Good afternoon. I'm happy to be with you here and welcome you to the new exciting program for developers community. This program is developed by Microsoft in partnership, very close partnership with Accenture and TVG. And this is a 4-month program for Baltic's developer community for you to learn, to collaborate, and to get inspired. For me, developers are the base for each and every transformation and innovation. Developers are the ones who can turn dream into reality. Developers are the ones who are transferring those user discussions into real functions and real systems and real applications. And despite the bias that developers like to work individually, I have totally different experience. Already from my study years, I remember and I feel this great sense of community that you can get if you are part of the developer community. And this is community where you can openly ask questions, when you can discuss all the challenges that you have. This is the community where you always will get support. This is a community where you can dream together about new cool features and new scenarios. This program is really for everyone. For those that are just starting their journey into cloud and development in cloud, and those that are exploring new technical areas, and also for those that are professionals that already are deploying business critical workloads on premises or in hybrid environment or in cloud. And you definitely also will find many interesting things in this program. And I also encourage you to share your broad experience with those that are just started the journey, so that they can get this inspiration for you and get as inspired as you are about development. You will agree that nowadays it is very critical to continue your learning journey. It is not something new for developers, because I think you are always learning something new. Research shows that those that are continuously developing their skills and going through certifications are actually more demanded in the market. So I hope that also this program will give you new opportunities for your professional development. And I hope that you will enjoy the program. You will enjoy the community around and those great experts who are ready to share their experience, their wisdoms. This will be also the place where new great ideas will be developed, and let's see, maybe some of them will become very real. So with that, I am welcoming you to this program, and now I'm giving floor to my colleague from Accenture. Anton, the floor is yours.
Yeah, sorry, Anton, you need to unmute yourself.
Sorry, yes. So thanks, Renate, for starting the program and giving so inspirational speech in the comments. I will try to build something on top. I'm very glad to be here and be part of this event. So I have double celebration today. So my daughter has a birthday, and we are starting the program. So what else I can dream on for this? building on top of Renat just saying, so we are living in the age of transformation. So everything is transforming around us. So the business being disrupted, decoupled, and transformed. And we are, as a developers, is definitely part of this process. And not only developers, but also end users and being like consumers of this transformation, like end consumers. And I believe, at least I'm looking for myself, that also I'm transforming myself with all this process. And we all remember the desktop apps or Windows Forms, then the web apps, and now we're lifting those to the cloud and adding native cloud features as a cherry on the pie. And that Microsoft basically have everything which is required to make this journey lovely for developers. So the Azure is a cloud platform, .NET is a framework, Visual Studio is the most popular IDE in the world. And I'm not talking about the SQL database and all the features. Plus, also the ton of new features becoming available every quarter available for developers for use and try and have fun. And I would say cloud also is becoming more affordable and also closer, I would say physically closer to the Baltics, with a new data center opening this year in Sweden and the new centers announced in Poland coming on. So let's use this moment, learn, share basically the things we know and maybe we want to know. And let's take advantage of being part of this community and have fun. So with this, over to Yanis Bruzhans, who will be moderator for the event today. Thank you.
Hello. Hope you can hear me, and let's quickly go over what this event is. What is Baltic Microsoft Developers Community? Well, most of you subscribed on the meetup page to something which we haven't really been talking about or explained what it is and how it looks like. But in short, well, we are a community. That's the simple part. What we want to do is organize meetups. We'll talk about it a bit later, and this is the first one of them. Today, we'll have 3 topics, 2 great speakers from our, well, close neighborhood, who'll be talking about different topics about Azure, and we'll do some extra introductions about what the community is and what we are planning to do in the very end, so stay tuned for that. But for now, let me just shortly jump over what we're planning. So 4 meetups. Time is already known. Well, we haven't announced them yet. We'll do it right after we finish up with this meetup, so you can subscribe already for the next date. But they're going to be on Thursdays, once a month, and you know the time. The end goal of this, well, series of meetups is to have most of you and many more participating in OpenHack that will happen in June. Before that, we also have an additional kind of meetup stream for everyone willing to learn or can do some more hands-on and practical tasks with Azure called Let's Build, where we kind of focus on self-study and building working applications together separately and yet reviewing what's the progress. And we're also starting Discord as a means to communicate with the community. The link will be shared after the meeting and I'll post it in a minute in the Q&A announcement section. So every one of you can already start joining there, but it's intended to be a place where we can talk in between the meetups. So feel free to join and I will welcome you there. But yeah, let's start with the topics that everyone arrived here to see. And I will give I give word to Dmitry. Hello.
Hello, Yanis. Thanks a lot. Let me share my screen and we will start. You can see my screen now, right? Okay. So it's my great pleasure to be here and to introduce you to Microsoft Cloud. And the title of my talk is Why Cloud is Good for Developers. And I will start with a short personal story. It all started when I saw one of those videos on the internet when a person photographs himself like every day and then puts together this kind of time-lapse video, which shows how they grow. And I thought, I want to do something like that, but how can I do it if I haven't been photographing myself every day? Probably I should try to do something with existing photographs and like align them together and do something like that. How can I do that automatically? And that sounds like a nice problem to solve. We know that nowadays we have facial extractors which can figure out how to work with those kind of pictures and extract facial landmarks. And starting to work on that, I came up to the idea that we can also use it to draw nice portraits of people. And I started going into the field of science art. But I will tell you more about that. Let's first start with the cloud. So why cloud is good for developers? And let me start with a nice definition of cloud, how to think about the cloud. So the best way to think about the cloud is that it's a way to abstract the place where the software, the code will run. So as a developers love writing code, but we don't want to think where this code would be deployed and how this will all work. We just want to write code and make it work. And cloud helps us to do that because we don't need to worry about details. The cloud would take care of scalability, of elasticity, and security, software updates, and those kind of things. We just need to provide the code. And in the essence, cloud is based on some kind of hardware because, like physically, it is the same. It's based on the same computers that we are normally using. But on top of that, first of all, we built the abstraction called infrastructure as a service. So the cloud consists of two main parts. We can run code, which is called compute, and we can store data, which is called storage. And on the basic level, we can use those in the cloud. Like if we want to create, for example, the virtual machine, which would run some kind of code, we can create a virtual machine. And that would be very similar to the normal computer that we are using. If we want to have the number of computers and if we want to develop an application which would be based on microservices, there would be like several, you can use things like Azure Batch to create a cluster of computers to compute things in parallels, or you can use Azure Kubernetes cluster to run the microservices application. And all that can be done at scale and very easily. The essence of cloud is that once you need computing power, you can always get it very fast. And once you don't need it, you can get rid of it. Another part is storage, and there are a lot of different ways to store data in the cloud, starting from normal databases like Azure SQL, relational databases, and some NoSQL databases. In Microsoft, we have developed a technology called Cosmos DB, which is based on combining different types of data storage solutions. Like you can store JSON documents, you can store graphs, and all that with a unified API. So those are infrastructure as a service services. And if you have some kind of infrastructure developed for your solution, like, for example, you already have the server working in your garage, the easiest way to move it to the cloud would be to use infrastructure as a service. But if you want to build an application from scratch, you can use a higher level concept called platform as a service. So platform as a service takes care of all the details. For example, you can say, I want to run a web application. And if you were using a virtual machine, you would need to think like, I need to put the web server software on this machine, I need to update it, and so on. But with platform as a service, you just say, I want a web application. I want a web application developed, let's say, in Python, in Django. And the cloud provides you like this place where you can store this application and run this application. And it will even help you to scale this application. if it becomes if the load becomes higher. If you want, instead of web application, if you want to develop a chatbot, there is a separate platform service called Bot Framework, where you can pretty much write the code for request response logic and have this bot available in different platforms like Telegram, Slack, or Microsoft Teams. If you want just to run a piece of code in the cloud, you can use Azure Functions. And this is very convenient way. For example, if you want to develop an API, if you want to develop a service which somebody else will call from outside, or if you want to react to a certain event. For example, a very typical scenario would be once you upload a photograph to make a timestamp, like to print the date on top of the photograph automatically. And you can define the function which will detect this event, photograph uploaded to the storage. It will trigger the code. It will receive this photograph as an argument and then do the logic. And there are similar platform level services, for example, for Internet of Things, for IoT, if you want to collect data from sensors, for machine learning, if you want to train your machine learning models at scale, and if you want to process big data, there is a service called Databricks, which takes care of many things for you. Like normally to do big data, you would need to think about like having a cluster of computers. And starting up this cluster, stopping it when it is not needed. And Databricks pretty much gives you the command line, the notebook, the Jupyter notebook, at which you can type commands, and it will create clusters when it's needed, and you can shut it down if it's not being used. So those are platform level services, and they allow you to build your system from like simple building blocks. For example, if you want to build a bot that will do something with your photographs, you can have bot doing the communication with the user. You can have Azure function doing the actual logic behind the scenes, and all that would work as the single software system, pretty much based on platform microservices architecture. And there are even higher level services, which I called here Platform as a Service Plus, because they can do even more high-level things. For example, cognitive services. Cognitive services, they handle some kind of intelligent problems, like detecting objects and pictures, or recognizing pieces of text, recognizing sentiments of text, and so on. Those are based on pre-trained machine learning models. And normally, if you want to develop a functionality like that, if you want to develop a model that would detect, for example, an age of a person from a photograph, you would need a huge data set to do that. But here you have this service provided to you already trained on the data set, and you can just call it as a function and get back the result. Finally, there are also some solutions which do not require coding at all, because there are some business users who want to use some automation as well. For example, in many business processes, they depend on some document coming into the email, and then you need to do some kind of very standard procedure with this document. For those kind of things, you can use Power Apps. It's pretty much the logic which will react to some kind of event. And you can graphically, without any coding, put together the diagram, what you want to do with that data. You can call cognitive services. You can, for example, extract key phrases from the documents and have the key phrases sent to you by email if you want to receive like a digest of the document sent to you. And those things you can do without coding at all. Another example would be Power BI, which is the tool to build the dashboards, which can access data. And all that also without coding. So that's the very brief overview of the most important services in Microsoft Azure. There are actually many more. And if I showed you like the standard diagram which we normally show at developer conferences, you would be lost because there are like 100 services. But I think those are the most important ones to know. And if you are going to think about building something on Microsoft platform, you can like think which services would be more useful to you. For more details, I'm sending you to the links slide, and there is actually one link which you need to remember from here, is easyfi.net/azref, Azure reference, and it contains all the links on the slide on that web page. So that is pretty much links to Microsoft documentation, but to right places in Microsoft documentation, which you can start using to learn about those services. So let me start coming back to my problem of building like video of with the faces of people and those cognitive portraits. Those are based on cognitive services, and as I mentioned, cognitive services are pre-trained machine learning models that can solve some artificial intelligence tasks. So, for example, there are services related to computer vision. There are services which can handle speech, for example, recognize speech to text and text to speech. There are services that work with language. For example, if you want to build a chatbot which will interact with you in a natural language, you can train the model to recognize phrases using the service called LUIS, Language Understanding Intelligence Service, and so on. So the idea of putting pictures together actually is based on a cognitive service called Face API. And Face API does all the things with faces. Like it can detect if the face belongs to the same person. It can get age, emotions of people on the photographs, and so on. But it can also detect so-called facial landmarks, which are points of interest inside faces. So that's how it looks like when you what kind of points are extracted. So coordinates of the most important points on the face. And for us, if you want to put photographs on top of each other so that they look nice, we pretty much need 3 points. We need like 2 points of eyes, like coordinates of eyes, and then we need a third point to build a transformation, because we want to transform a picture by rotating it and moving it around in such a way that it aligns with all other pictures in the collection. And this is done using the technique called affine transformation. So affine transformation is the combination of shift, rotation, movement, translation, and so on. So affine transformation is pretty easy to do in Python, because in Python there is the very beautiful computer vision library called OpenCV. And with OpenCV, it contains actually a function to do the affine transformation. So we just need 3 points. We need to say like those 3 points move to another 3 points. So for the face, we can take, for example, 2 coordinates of eyes, and we can take, for example, the middle of the mouse, this kind of this point and the intersection, which we can calculate also from coordinates. Let me show you how this actually works. And to do that, I will use the technology called GitHub Codespaces. I have the GitHub repository, which is shown here on the slide, which contains the code to produce those cognitive portraits. I will show you the repository. Here's the repository. You can see there are many ways you can put photographs on top of each other. So this is the very simplest one that I experimented with, just putting a series of pictures together. And then you can also like think how you want to align them. Do you want to like put 2 faces next to each other? Do you want to align faces in some more clever way, and so on? And there are even some contributions from other people to this repository. So if you want to get creative and if you want to think like what can you do with photographs based on the facial landmarks, you can contribute to this repository and do a pull request here. And the best way to run this code, this is the Python code, which is just stored somewhere on the GitHub. The best way to write this code in the cloud would be to use something called Codespaces, GitHub Codespaces. GitHub Codespaces is the technology which is currently in preview, so you would not have access to this functionality that I will show you now, but you can request it, and they are opening this up gradually to people who signed up for it. So you can immediately after this event, you can go and apply for GitHub Codespaces, and you would be able like to start with any repository and say, I want to open it up in Codespaces. And then pretty much it will create the virtual machine for you and open the container and open the Visual Studio Code editor right here. And you can also open it in the Visual Studio Code editor on your machine if you want. But you can also start editing in the browser as well. To save time, I will open it the same repository in Visual Studio Code. So it's pretty much explains everything which goes on. So if you want to create this kind of combined portrait for your friends, it actually makes a very good New Year present. That's what I did this New Year for all of my friends. You can use this repository. You just need to put photographs somewhere in this directory, and then the code does all the magic for you. The only thing you need the key for the cognitive service, which you can get from if you have Azure subscription, you can create the Face API cognitive service there. If you don't have the subscription, you can get the trial key, which would be good for 1 week. And the link to get it is also here inside the Jupyter Notebook. So pretty much this service allows you to do one function call. So here is the example. I pass it the URL of the picture of this one, which is somewhere on the internet. And they tell it, please detect age, gender, emotions, and so on from this picture. So if I run this, it gives me age 41, gender male, and so on. And the emotion is happiness. And even I have 0.6 mustache and 0.4 of beard here, which is kind of what you can see on the picture, reflects it pretty accurately. So then what this code does, it takes all the pictures from the directory, processes them, extracts those facial landmarks, and you can see the coordinates, they look like this. It's an object which contains X and Y coordinates for all the important points. And then we can take those photographs and align them using a fine transformation so that all photographs are aligned in this manner. You see that eyes are in the same position. So now when we merge all of them together, they would look nice. And to merge them together, we just do again one function call, and here we get this averaged out photograph of a person. Again, if you want to contribute, please do. And so the takeaway that I showed you now, what we can benefit from the cloud, I used pre-trained neural network model, the cognitive service, which does already a pretty interesting thing for me automatically. And I also showed you that it's pretty easy to run Python code online without installing anything on my machine. Next thing, when I did this technique of developing cognitive portrait, I thought, how can I do something great with it? And in the beginning, at the end of last year, like in autumn, one of the museums in Moscow called the Electro Museum, they made an open call for pretty much everybody interested who wants to take part in our exhibition. And I thought of creating the exhibit for the exhibition, which will photograph people passing by, like those who stopped by this stand. It would take a picture of them and blend different people together who visit the exhibition. So to do that, what I would need, and this is the early prototype, by the way. It takes pictures like every second or so, and then it blends them together. And you can see me and my daughter, we are like testing it on our face, and it looks like our faces they get slowly merged into something like similar to both of us. And to do that, what I need a client which will run in the museum in this exhibit, and this can be a UWP application, because UWP is so great that it can recognize faces automatically without the landmarks, but it can recognize the presence of a person in front of the camera. And this is something we desperately need, because we don't want to, like, every second to send to the cloud photographs which do not contain anyone. So we wait for the person to come in front of the camera, and then we use Azure Function. As I mentioned, Azure Function is the easiest way to run the code in the cloud. So we run this code in the cloud, we store the picture in the Azure storage, and then we return back the combined picture. That would be the logic of this exhibit. And what's interesting, we can put it in different places, like in different museums, for example, and it will blend people from different geographies together into one combined portrait. This is, I think, a very cool concept, which is nice, which gives a nice idea to this exhibit altogether. So how can we quickly implement the solution like that with the cloud? So first of all, let's start with UWP application. I will not like show you in detail how it works, and if you want to check, there is a GitHub link here. Pretty much it's the application, it's a sample application, and I will show you how it works. we take the we develop it using Visual Studio. So you have this UWP page, and as soon as person appears in front of the camera, it does this countdown and it takes a picture. If the person moves away and another person appears in front of the camera, again, it does the countdown and takes the picture, and so on. Right now, it doesn't have any logic to call the cloud. It's just taking pictures. And here is the place where we would show the final portrait once everything is completed. Next, let's switch to the Azure function. Azure function is the most interesting component here because, first of all, we want it to run in Python. And some people think that, like, if it's Microsoft Cloud, that you can only write things in C#. And that's definitely not the case because Microsoft Cloud is like pretty much agnostic to the specific technology. You can develop websites in PHP even, although probably you should not do that, but you can if you want. And you can write Azure functions in Python. And Python is, as I mentioned, is a good candidate here because we need to manipulate images. So for Azure function is pretty much a way to structure your code and deploy it somewhere as a callable service. Or as a service that would react to a certain event. So you can develop Azure function locally. And to do that, you need to install Azure Function Core Tools, a special SDK to develop Azure functions. And once you do that, you can initialize the local Azure function, which would run on your machine. So let's do that. So I will do func init coportrait. That would be my Azure function, and I would say I want to write it in Python. And then inside the function, I can have several endpoints. So I will create the endpoint called pdraw, and the template would be HTTP trigger. So it would be a function which reacts to HTTP request from outside. So once I have done that, I can start this function locally on my machine. And this is the easiest way to develop because I would see like everything that function prints out. I do not depend like on the internet for a while I'm developing it. So you see, it starts on the local web server, and I can now call this function. It gives me the address, the port 7071. I can go to the browser and I can paste this address here. So if I just go to this website, it would show me that it's a function website, and if I specify the correct URL /API/pdraw was the correct URL, it would give me the result of my function. So right now I have just instantiated the function from the template. So this function looks like this. It's the pretty much Azure function consists of two parts. Python function, which is being called. So this is the main Python function, and you can see that it expects HTTP request as the input parameter. So whatever I pass it, it will get as an input. And as a result, it gives back HTTP response, which is the result I want to return to the user. I can also write a function which would be triggered based on an object placed, for example, inside the storage. In this case, this object would be passed as a parameter. So if I want to create a function which will timestamp the photograph, I would get the binary photograph as the parameter, and I would need to return a binary photograph. And this Azure function runtime would automatically take this and place it into the required storage. So another component is this function.json file, which defines the binding. I can bind the function to certain cloud objects. Like I can say, I want to bind this function to a table in the database. And by doing so, I would be able to write to this database without writing the code to access the database. I would just say, I want to return an object which is being then inserted into a table. A good example would be if I want to create the application which would show me the statistics of emotions of people in front of the camera. So I would send the photograph every second. It would extract emotions using cognitive service and return the result and put it into the table. Very easy to implement using Azure functions. So in my case, my Azure function would do three things. I would not go through the code in detail. It would store the original picture in the blob storage. And this is a few lines of code. Then it would process an image, call the cognitive service, apply a fine transformation, and put the resulting image into the storage, another storage called cmapped. And then finally, I would take the 10 last photographs from this storage called cmapped and put it into the storage called out. And then I will return the URL of this picture in this storage. This out storage would be public. So my Azure function, instead of returning back the picture, it would return me the link, because that's the easiest way for me to put it into the UWP application. In UWP application, I can just put this URL into the image object, and it would be fetched automatically from the internet and shown in my UI. So that's how it is, and you can see how it works. I have this code. I can now start this function locally, and I can debug it locally, like for example, using Postman to provide all the parameters to my call, because in this case I need to put in the binary image as the parameter. So I would specify binary in the body of the message. I will choose a photograph, and I will call this. I will click send, and as this function is being executed, you can see that everything is printed on console, so I can debug it very easily. I can see that the function executed, and here is the URL that I get as the result. If I take this URL, paste it into the browser, it will give me the resulting picture like this. Now I need to deploy this function into the cloud, and this can be done using command line, or I can create this function in the cloud using command line, or I can do it through the portal. To save time, I will not do that, because that's not very interesting thing. You just type, and then the function is deployed. And finally, to integrate it into our UWP application, we need to write the code to call this function inside our code. So that would be also a couple of lines of code. We here insert the function to call the service, and then assign to the bitmap the URL that we receive from call cognitive function. And call cognitive function would be a simple HTTP request. So in .NET, there is an object called HTTP request, and we can say HTTP post async, and it would do the post call to the Azure function. So that's just a few lines to call the function. So what we have done now, and I will show you now how this application runs. We have created this client-server application with the Python logic in the cloud and C# logic on the client side, which calls the pre-trained neural network to do the job. So I think that's pretty cool, isn't it? And with the cloud, you can do it pretty fast, because you do not need to. You just putting together a thing from the simple building blocks. The first time function takes quite a long time to run, and then it becomes faster, because the first time it needs to fire up. Okay, so I've shown you that it's easy to run pieces of code in the cloud, and it's easy to store binary objects in the cloud as well. So the next thing that occurred to me is that I should probably write it a chatbot, to turn it into a chatbot, because this exhibit was actually shown in the exhibition for 1 month, and then the museum showed closed for lockdown. That was the March of last year, I think. It was February, March in the museum, and then in March the museum closed. And I wanted to bring this experience to people online, so I decided to build a chatbot. It would be an extension to this architecture, and with a chatbot, it's pretty easy to develop a chatbot. You just develop the chatbot using bot framework, and the chatbot pretty much looks like a client-server web application. So there is one function which is responsible for request response, which is like here, and we need to replace this call by the call to our Azure function. Pretty easy again. I will not. I will probably skip this demonstration a little bit. So we deploy the bot to Azure, and that's it. We get the running bot, which we can then connect to different channels. For example, we can get this bot running up in Telegram pretty fast. So it's also easy to create chatbots using platform services and easy to host web applications because a bot is a web application as well. So I also made it available as a website. So I encourage you, after you finish this event, to go to this URL, easyfi.net/peopleblend. And this application would allow you to take a picture of yourself online through the browser. And it will blend all the pictures of all participants together. So let's see today, after the end of this event, the blended picture from all participants. And I'm looking forward to see it as well. So please go visit this URL and try out this application. Or you can also try the bot in Telegram, People Blender bot. It uses the same backend, by the way. So if you post your picture in Telegram, it would also be available on the website and vice versa. So those are the main things I covered: web apps, bots, cognitive services, serverless storage, and DWP apps. And I think it should be enough to show you that using cloud is like very pleasant thing to do, and it gets you as a developer very productive. You can put together incredible projects in a very short amount of time. And this is finally like one beautiful thing that came out of this exercise. I managed to like this shows how my daughter grew up. So it's called Growing Up, and it automatically sorted all her photographs into different ages and put them all together in the blended picture like that. So thanks a lot for your attention. I hope I made you believe and I actually got you enthusiastic about exploring more about Microsoft Azure. Okay, the excellent question I see in the Q&A: how much does it cost to run such an exhibit in the cloud? That's a great question, actually. So the cloud, the cost in the cloud consists of Azure Function and cognitive services. Cognitive services, they are pretty cheap. It's something like $1 for 1,000 calls. Running Azure Function, you can use two modes of running Azure Function. You can run it on a dedicated compute, in which case you would be paying like for a small scale virtual machine. Or you can run it in the serverless mode. In the serverless mode, you just pay for the number of calls, and it does not have to be running like all the time. It's automatically like scaled up and scaled down. And serverless mode is really great because if you're not doing a lot of calls, you're not paying a lot. And in the exhibition, as always, they run many times when people are just not there in the museum. So and you would not be paying for that time. So cloud is very scalable in this respect. Another question: how accurate is age detection? The answer is I don't know. I have strange experience. Like when I was playing with the age detection first on one of the hackathons, it was a student hackathon, so all students were something like 20 years old or maybe 16, 18, and there was one girl who was always recognized as 6 years old, even though she looked pretty normal, like for us, to us, and to neural networks, she was 6 years old. So sometimes it can be a little bit inaccurate. But on the other hand, I don't know of any specific studies. And the best thing to do would probably to run your own study. It might also depend like on the type of the face, of course. But I think the data set that it was trained on was trying to be pretty diverse as well. Okay, and the question is it possible for an individual to afford cloud services for personal and commercial purpose? And the answer is definitely yes, because, well, as I mentioned, if you are like, if you think about costs, you can minimize them pretty effectively. And first of all, if you are a student, you can get cloud like for free for like as long as you study, and there are a lot of services which are free for you, like all the time. As a student, you get a certain amount of credit, so you can like spend $100 on any services you want. But then there are a lot of services which stay free for the duration of usage, and among those are bot framework, websites with some limitations, of course. But you can set up a bot which would be free for you. And cognitive services, I think they are limited to something like 30,000 calls, which is also quite a lot. For individuals, there is Azure trial, which you can try for 1 month. And then again, for 1 year, you get a lot of services for free. including, I think, a free tier of cognitive services with 30,000 invocations. So yeah, if you need this kind of functionality that I talked about, that would be pretty cheap. And I will type, I think, some of the links in the Q&A, how to get cloud for students and how to get cloud for free trial. So I will type it after my presentation. So if you have any further questions to me, like if you want to share your experience, if you want to like build something on my code, feel free to get in touch. And I will also post the link to my website in the chat. Thank you so much for your attention.
Okay, as we still have a couple of minutes of time, there's still one more question about cognitive services. So can this cognitive service be used to detect the intent of an email? Let's say to detect emails that could be routed to specific receivers.
That's a great question. So there is a service called Language Understanding Intelligence Service, LUIS, which is focused on intent detection. However, its main focus is detecting intents in chatbots. So probably there is some limit to the length of the phrase. So one idea would be to use this service, yeah, I think that would be the first start. And you would need to train it on some examples, and then it would give you the correct intent. And I would also, if I were solving this problem, I would also try to train my own model, because there are now pre-trained neural networks like BERT, and it's pretty easy to build classifier on top of BERT yourself. So like you can use Azure Machine Learning or just virtual machine with GPU to train your classifier yourself. But that would be definitely more complex thing to do and more resource consuming. Okay, thank you again so much. We have a short, I think, time to go and grab a drink if you need to, but very short time because we are almost about to start.
Okay, let's not delay any longer. And next speaker for us is Karl Slavinch, and he'll be covering two topics, but let's start with the first, Azure Devops. Karli, the floor is yours.
Hi, good evening, everybody. I'm super glad to be here. It's actually going to be a bit more than two topics that I'm going to cover, but you'll find out about that shortly. But no worries, they're going to be interconnected. So, let's get cracking with the agenda. So first, I'll do a short introduction to DevOps as such. Then we're going to look at the DevOps tool from Microsoft called Azure Devops. Then we'll look at application insights as the application performance monitoring solution. And then we're looking to the continuous monitoring for continuous learning to tie the two together. All right, let's get cracking. And one more remark: if at any point in time you have any questions, please, Giannis is there to read those from the chat and actually, convey them whenever he feels like it. Yeah, so don't be shy to ask. I'll try to answer to my best ability at right now, and if something stays in the air after my presentation, we'll follow up on that. All right. So what is DevOps? Over the years, I had the chance to read quite a few interesting definitions, about the topic. And the one that I actually like the best happens to be from Microsoft, and it says that DevOps is actually a union of people, process, and products to enable continuous delivery of value to your end users, the users of your application. So that's a really important thing to grasp: a union of people, process, and products to continuously deliver value, not just once, but the more, the better. What are the technologies that really support DevOps or concepts rather? There's three basically that really need our attention at this point, which is continuous integration, which is a way how you improve software development quality and speed by ensuring that every time a code gets merged in, you do a build and run a test and make sure that thus far there are no problems, that it looks fine, and then you don't find out whenever you go out and try to release something that you actually can't even build your code successfully. Yeah, with continuous delivery, we ensure that we automate continuous delivery and deployment. We make sure that we can automate the release process and make it repeatable, so you don't turn your release an event, but that becomes a regular thing that you can do multiple times a day without any extra stress and with confidence. And finally, continuous learning and monitoring, which is also an important piece. Use developers no longer can just say fire and forget, release your code, and then whatever happens, happens. Sometime we get some more work and then we'll continue, developing our product. With continuous learning and monitoring, you actually ensure that you track the performance and the usage of your product to make sure you can pinpoint what to improve and what to work on quickly. You discover bugs more quickly, you discover issues more quickly, and you can focus actually on the features that are used and most popular by your users, and kind of veer off and not do things that are not that important to your users, because you can or should look at them and track them. Yeah, if we look at the release process itself, then this little picture also does a great way to illustrate what happens in the continuous integration part of the process. And you automate the build, but you need to think about it as a mindset and a team strategy to ensure again the quality, and through that also you deliver the value to your users by ensuring that hey, the code that we release is actually up to par. Yeah, and some integration practice, continuous integration practices that we should discuss and come into display is decision on will you use a single or multiple repositories, and the implications of that. Of course, that's there's no really a one universal good practice to each team. Whatever makes sense, they do. With Mono, you figure out that you will split up, for example, services per folder of the code, and you have all the code in one place, and refactoring is made easier. However, the code grows over time, and with multi-repo, you split and have a repository for each service, and then the oversight of overall code becomes a bit more complicated. You work and focus on using trunk-based branching. So basically, you do create short-lived branches in which you do the development, and you quickly then integrate them back into the master branch. You also do introduce branching policies to ensure that developers no longer can directly contribute to the master branch, that there are quality controls, and team works efficiently together by performing pull requests and reviewing each other's code before that code even gets merged in. And you also try and you should try to go and perform security scanning on your code to make sure you don't leave any credentials in. There's no, screaming gaps of security in your product. So important to focus on those things. So it's just not just tools, and of course the tools and the tool that I will discuss later in this presentation obviously make these things easier to achieve. But in the end of the day, it's all about the culture and the collaboration within the team, because not everything can be automated and not everything can be enforced with tools. Definitions of ready and definitions of when the work is complete, these are internal discussions, and there's of course a lot of guidance on how to set that and agree upon that. But that's again, a collaborative effort. And all that is done to achieve, again, a quality code. All right, on the side of continuous delivery and continuous deployment, any code changes that pass the continuous integration process are automatically published to production-like environment. And then the deployment is done to production, usually with a manual approval. And when the team grows and is more confident in the process, you can actually go and introduce quality gates and automated checks to ensure that you can go from continuous delivery to continuous deployment, which ensures that you can release constantly to production automatically without any human intervention in this whole process. So the continuous delivery practices that you should focus on and are kind of tried and tested is to have everything in source control. So Dmitry demonstrated how he can deploy and create resources in Azure using command line or through portal. There's the third way. There's an Azure Resource Manager API that actually allows you to describe using infrastructure as code any single piece, any resource you want to do in Azure as a code, which basically means that not just your code that you write, but also the definition of the infrastructure on which that code will run, be it a server with all the dependent components, because when you run a virtual machine, it does have to have a virtual network, it does have to have a storage, some disks, a network interface, and additional configuration. So you don't ever want to be in a place where every time there's a release, you have to go in and for multiple environments, set these things up by hand, because that introduces configuration drift and you introduce breakages, and that is not a nice thing to do. That's why you should strive to have everything in the source control, not just your own written code, but also the infrastructure definition. And that's also one great thing with with cloud is that you can have that. You can of course achieve that on premise with expensive tools, the ability to not just define what's on the virtual machine, but the whole configuration process. But that is a whole different story. And you also of course want to ensure that the builds are automated, as mentioned before in the CI part, to make sure that you don't discover during build process that something is awry and not working properly. And you also should build just once. And the set of artifacts that you build should not differ from dev, test, pre-prod, and prod environments. So everything you have there is written once, so you don't have the excuse of, that runs on my machine or the development environment or anything, insert your excuse why it suddenly didn't work in production, but did work in dev test environments. Yeah, and your trunk should always be production ready. So you can release and quickly, even with doing a release, because that what's in your master is actually working code that's fine and dandy. So you can always go back and release a fix on your code. And besides, when you do integrate code often and in small chunks, the scope of the problem, or rather the code that you need to review to figure out the problem, is a lot smaller. With feature flags, this gives you an opportunity to release a feature, but not enable it, or enabled it gradually over a period with some test users starting. And when you have the confidence to do so, you can enable those features for a wider audience. Yeah, for blue-green deployment, again, yet another healthy way how you can release to production with zero downtime by having two identical environments and then just switching basically a DNS record to point to your previous, development slot or staging slot to production with zero downtime. And canary deployment is also a great way how to test a new feature on just a subset of users, while the rest of the users continue to use, previous stable version. Right? And continuous monitoring, I'll look into this topic a bit more with, application insights, which is part of Azure Monitor. But the main goal with this is that you introduce monitoring in your DevOps lifecycle, and you actually monitor and track the usage, the issues, the performance of your code, and try to figure out whether your new release did actually mess up the performance of your solution or did it improve or not. And based on that, you can then take that input and actually use it to plan your future work. Would you need to focus more on the new feature that you released to make it even better because it's used by a lot of people, or should you focus on improving the performance of existing features because, well, for whatever reason, it doesn't perform as quickly as possible. So those are a couple of things to take note before we start diving into the tool, which is from Microsoft. It's called Azure Devops. Yanni, do you have any questions for me thus far?
Yeah, I kind of was wondering about the canary releases that you mentioned. So
yes.
Have you had any experience what kind of requirements it sets for the application itself? So I imagine you need to have a very distributed application for that to work, or what is a good fit for canary releases?
It actually depends on what you're running your application right now, but typically you would either have depends on where you host it. Like in Azure, you can do that in a virtual machine. In that case, you would have a clone that would run the kind of the new version to which you canary some of the users. Obviously, that implies that when you write the code, for example, there's a database that needs to be the new code needs to be backwards compatible with the database schema, so you can have the new features and still work without changing the database. For example, when you use PaaS service, the Azure Web you can deploy a thing that's called a slot, which basically is a copy of what you have there. And then in that case, you kind of unify both the blue-green deployment and canary. So you deploy the code on the staging slot, and then you let people on it. Like, for example, you specify automatically in a template that 5% of the users will go to the new version, which in turn, still is not in production. And then you run it for a period of time, and you validate that, hey, both the users are satisfied and we're not getting any performance issues or any bugs. And then you do a switch, basically redirect the DNS record to switch around, and your current production becomes staging, and your staging becomes a production. What is nice about it, it has zero downtime for the end users, or rather you can do it the zero downtime way. And if for whatever reason you discover after that swap that, hey, there is an issue that the 5% or how many percent of the users you point out to that second slot, you face a new issue, you can always switch these slots around and you still have that previous working production version of your code still available. Does that answer your question, or would you like some more details on that?
Yeah, this does answer plenty. We have one comment in the chat regarding that GitHub now supports continuous deployment for Blazor websites. This was in preview a few months back. Yeah, I'm actually a big fan of the static websites, so this is actually cool.
Yeah, that is true. And also, you probably have seen that Microsoft has acquired GitHub, and actually, since we can agree that this talk is going to be about DevOps, but still I want to make you all aware that the GitHub is also ours, and a lot of new features will be going there. And some of the things that I'll talk when discussing Azure DevOps actually are possible in GitHub. So you're currently using GitHub. We'll get to to the CI/CD part and how you do that. You can actually still use GitHub and rely own functionality of Azure DevOps. We'll get there, and you know, that's our product, and we'll be developing both of them side by side. So Azure DevOps is not going anywhere as well. So anything else I can handle just this second?
Nothing on the radar, unless somebody
Good.
is really quick with posting.
All right, let's then move forward. So Azure DevOps, that's a product from Microsoft for, you know, doing DevOps. And briefly, let's take a look at the numbers. These are slightly dated, so obviously they've gone up. But at the time these stats were collected, the DevOps was used by more than 90,000 internal users in Microsoft. You know, that's not just developers, but also architects and engineers. And we did about 78,000 deployments a day. And if you think about the portfolio of products we have, yes, Azure itself has more than 100 different services in there. But you know, if you think about, you know, all the operating systems for server, for all the systems for middle layers, and you would figure out that you can see that there's a lot of builds happening every single day, and a lot of deployments happening every single day. So, you know, to achieve that that cadence of releases and that velocity, you can't really rely on manual processes. And DevOps has long been used in Microsoft and will continue to be used for a long time. So as an introduction, basically DevOps consists of 5 unique components which are well integrated together. That's Azure Boards for basically tracking and operating and planning your work and discussing the work in your teams. You know, Azure Pipelines for doing build, testing, and deployment with continuous integration, continuous delivery, and continuous deployment. Works with any language, any platform, and any cloud, and on-prem. Yeah, so you're not limited just to doing this in Azure or just Microsoft technology stack. You can connect it to the GitHub or any other Git provider and deploy continuously using it. Azure Repos, so that's a built-in repository. We do support Git and Team Foundation services as version control, and you can use it as a distributed, you know, code management system. Azure Test Plans, so you can integrate the testing in your processes, as well as Azure Artifacts for, you know, fully integrated package management, and you know, you can use that to efficiently collaborate within your organization, where, you know, one team might be just writing a specific library and then you make it available through artifacts, either publicly or privately within your organization, using, you know, both public or private feeds. A bit more on Azure Boards and the rest of the services. So basically, it's a, you know, Kanban board, backlogs, team dashboards, and reporting mixed into one. Has multiple different ways to track work, starting from basic process using Scrum and Agile, and, you know, just typical waterfall approaches. And it allows you to, you know, track and measure the progress of your teams. And there's quite a bit of extensions also written for this. For example, a good and popular one that we used previously quite a bit in my previous experience was to hold retros. And then you can actually connect, you know, what's been happening in your progress with retros in one tool. And this is kind of the overarching theme of the Azure DevOps, that instead of using multiple products to achieve all this, you can use one interconnected solution that you know, helps you do all those things. With Azure Pipelines, you know, you have cloud-hosted pipelines and also, you know, our own agents with unlimited minutes of build time for your open source projects. Yes, you heard that correctly. If you have an open source project, you can use Azure Pipelines to build and do releases for free. Using any language that you would like to use, you can do the deployment on Azure, AWS, Google Cloud, or on premises. Of course, there's a bit of some things that you need to consider when you're doing the on-prem deployment, but, you know, also there's no nothing prohibiting you from doing that. And it's extensible. There's a lot of extensions available from Slack to, you know, post messages in a channel. for errors or successes, or Sonar Cloud to do code analysis, and various security solutions that allow you to do wondrous things. And and that is kind of the power that you yourselves also can see. Hey, there's a popular demand, and there's not yet no extension just yet for that particular thing we would like to handle. You can yourself write an extension which you can publish for free or even sell to other companies that would be interested in using such features. So explore this quite a bit. Also, it has great support for containers and Kubernetes. You can build, publish, and push images to container registries. And also, we do have in Azure, our own container registry, which you can use for free up to 10 gigabytes of space, if I recall correctly. So it's an excellent way also, to use whatever technology stack that you're into, be it containers or just doing deployment on virtual machines or on Azure services, because you have basically pre-written already, tasks and their definitions to do that. And in pipelines, you can do both the edits in the, quote unquote classical way where you drag and drop the items, and you can also do YAML in there. And what's cool is that, if in case, for example, you want to port this and have it in GitHub, you can actually, for every single action that you put in, that's done with the classic editor or so-called classic editor, you can actually see and extract the YAML definition of that particular task at hand, which, also is a good idea to make sure that your build and release pipelines are actually defined as a code. It makes it so much easier when you make code changes that require you to change the pipeline to have everything in source control, meaning, we follow the principle that everything you do is in source control. Yeah, and it's a perfect launching pad for it. Yes, I hear a question.
Yeah, sorry.
Sure.
I'm going to interrupt you, but so the question from Rain is, are there any plans to support work planning with feature dependency, feature branches like Team Gantt has? I'm not really familiar with Team Gantt, but
yeah, me neither. But basically, you can tie and say basically in a way you can with the boards you can actually enforce the connection between the feature that you work on and the task that's on the board by, that's a popular way how to do it is a branch protection policy, which means you can't really you can do work, but you can't really submit to a pull request a task that does not have a code that does not have a task or tasks assigned to it. So if that answers your question or doesn't, let us know, because I have to be that I'm have to let you know that I'm not super sure whether I answered your question with this. Anything else?
not currently. I think we can go on.
Good. Yeah, and there's an integration with GitHub. Mentioned before that you can actually use the pipelines and for open source projects totally free. That's our a way of showing love for open source, and for your private projects you can get up to basically 1,800 minutes of build and deploy time for free every single month. We'll get to look at the pricing of the DevOps kind of in the end of the presentation, but that's also something to remember, that you as developers starting on your small little project, you can start using this and the rest of the features that I'm going to mention for free today. And then when you grow to the size where you actually the team is big enough that it makes sense to start to purchase new licenses, then you start to do that from that moment. And that again is yet another testimony of the cloud approach, where you start small and we scale with you, and your cost accordingly scales with you. You want your project to fly before you open your wallet and start to take money out, right? With Azure Repos, as I mentioned before, there's a limited private repo hosting and support for both Git and Team Foundation version control. And works with any of your Git client and has API integrations, and you can do code search and great at tracking the history of code merges and pull requests and commits. So it's a great way how to host a distributed source control system in cloud. On test plans, you can run and define test plans and find defects and simulate users, both using, for example, mobile devices if you do mobile development, as well and integrate tests and figure out what's happening with your application and have an end-to-end traceability, which you could then again use to figure out, hey, are there bugs? And you can easily integrate your pipeline with tests, and then whenever a test fails, you can actually automatically create a bug item and assign it to the either specific people or the people that did submit the code for them to fix. So it's also a great way how to tie the story together with the quality of the code that you deliver. Yeah, and lastly, Azure Artifacts allows you to both share and distribute the packages, both internally in the organization as well as externally, and publish to open feeds. All right. Basically, the core thing here to know is that Azure DevOps gives you the chance to use the tools that for the clouds or on-premises environments to do your deployment. Yeah, there's a wide support again of various tools that are not Microsoft written. We love open source. We let you use whatever works best for you guys. Yeah, so don't be shy to try this out, and it's a great solution to work with. Any questions? Sure.
Yeah, there indeed is. So what are the limitations of the free DevOps version? At what point one should start consider to switch to?
Oh yes, that's actually, I can jump to that slide right now and then can come back to show off the kind of in demo, because I have a short walkthrough in the portal that I wanted to show. But basically, this is an excellent question. I love getting this question. So basically, open source projects for free. You can use the pipelines, boards, and repos for free for your open source project. For small teams up to 5 users, you can use all but the test plans also for free for up to 5 users. And the moment when your team grows to 6 users, and by users, I have to clarify, so it's a kind of bit of an unclear definition here. Users with license, because you can have an unlimited number of stakeholders who just have viewing rights in your project, and those don't pay a dime. But the moment when you want to have more than 5 users actually committing code, working on the boards and doing those things, you start to pay from the 6th user. You pay $6 a month, and of course, if you require more agents, so you can run tasks and jobs in parallel. Then you need to buy those as well as the additional time for your build agents to operate. One more thing to mention, we keep talking about Azure pipelines and Microsoft hosted. That means that we actually run a container with a specific configuration that executes those jobs for you in the cloud. But that does not mean that you cannot use your own build machine basically that does that. But then of course you need to really think what's more efficient for you to buy or keep somewhere a virtual machine that does that for you and maintain it and make sure you know it's in working condition and runs constantly, or is it just cheaper to buy some additional time on the build agents and expand that way. Of course, as a person that has come from the world of actually managing, servers on-prem, always prefer to buy a service that somebody else manages. Any more questions on this?
No, doesn't look like so. Maybe one thing I want
to
ask your opinion. Well, I am in a project that has this difficult situation where we have things in the cloud, things on premises, and we've been living with the on-prem Azure DevOps for quite a while. But how do you see with the cloud offering currently? Does it make sense when you have this hybrid deployment model to keep things mostly on-prem or mostly on cloud?
It actually depends on the requirements of the environment. Look, the fact that you have an Azure DevOps service in cloud, and yes, of course, as you probably, Jans, are aware, and maybe the others are not, there is a DevOps server, which basically gives you most of this functionality that you get, well, with the exception of testing on mobile devices at scale, and all the beautiful things that the cloud can give you. You can run this on-prem as well, and you can run the agent, but you can on-prem as well, but you can actually do this in a hybrid way. That for things that you build and release to clouds, you use one type of agent, and for releases, for example, you have some customers that are on-prem, you use a machine on-prem in their environment. That actually not just opens a security hole where DevOps service itself sends tasks in, but the machine in on-prem actually just calls out to DevOps and checks, hey, do I have any work to do? Hey, do I have any work to do? Basically, opening a secure outbound connection. And in that way, you can actually, based off what is the requirements, because there are customers that have very strict requirements in the environment, and even a service in cloud that doesn't open the security opening in their environment is a risk. For those, you use a Azure DevOps server on-prem. For those that can allow to have a machine for which the deployment will happen to on-prem, I would always go with preferably with a cloud solution, but in those environments where you have to do things on-prem, it always comes with a certain baggage. Does that answer your question?
Yes, it does.
Excellent. If you want to elaborate or have me elaborate on that, we can always connect offline and address that topic as well. How am I doing time-wise? Am I rushing? Am I on good speed, or how am I doing?
Well,
I've lost the track.
You have at least 10 minutes according to our initial schedule. So
good. Then in a sense, I'm rushing a bit. Happens. Just give me a second. I will switch over to the demo I want to show. I want to show bits and pieces of Azure DevOps. So it's not much of a demo, and then we'll take a little break, and then we'll move on with the application insights and kind of closing thoughts on. I'll reshare screen. Okay, just please let me know when you actually see.
Oh, should be good.
Should be good. Now I need to find the proper window in all of the windows that I have open. Yeah, so basically what you see right now, this is the Azure DevOps portal. This is the project dashboard of the Smart Hotels thingy that I did. It's actually generated from our own internal demo generator. And I'm sorry for the light on my face. I now see I have aura on me. I'm sorry, but you're not here for my pretty looks, but for the content, I hope. So this is actually consists of a bunch of widgets, and this is something you would kind of give to your project manager and your product owner to check on the status on various things. Work in progress, assigned items, bugs. Release statuses, and whatever things are there. You also have an integrated wiki, which in this particular case I haven't populated, but this allows you to define also the wiki itself as code and describe any things and features that you add and have coded and provide a wiki as well in the same project. So this is the kind of the goal of all this is to make sure that you can use one product for all your needs in the DevOps instead of relying for one product for tracking tasks and different one for holding your backlog and or rather code. So we can go in and there's boards as a concept where you can actually go in and track and move the work around and define the items. The definition here is just whatever is built or defined. All of this is based on templates. We have made 4 or 5 different templates available for how that are kind of as the most popular ways to control the work defined, but all of this is just templates. You can define whatever makes sense to you, whatever areas, whatever states, whatever details on priority or business value, like what value areas these are, architecture, client experience, business, or whatever. Yeah, so it's just a way how you can actually track this. As you can see, this is in regards to a question Helmut's asked, whether you can track a link to a development effort, specify a specific branch. I have only the main branch right now, but if you would create a branch, you can actually link the task to a branch in which you're doing the development, as well as to the tasks and related work. In this particular case, like this probably is a feature, yeah, under which there's tasks, and there's of course the concept of tasks and also epics. Yeah, so backlogs for defining backlog items, sprint control definition. You can formulate and figure out your sprints, and you can see the progress on the user stories and the tasks and time spent and time remaining. And with queries that you can write, you can actually take track and do control and see burn down and a lot of things that would make sense for you as if you're a Scrum Master also working on this. And again, it's all about collaboration, about making the collaboration easy for you not to run around like a headless chicken trying to figure out in which tool do you track what. You have everything in a single place, and that's what I love so much about this particular product. So the repo sides of things, there's you can have multiple repos here. I just have one. You can define ownership of specific code parts. Like here, for example, I have a deployment template as part of code. I mentioned that as one of the ways how to deploy resources. You look at this, basically I'll go to the build pipeline and the release pipeline. You'll see that basically I use the same exact deployment definition for infrastructure for dev, test, or in my case test and production, to make sure that always the same exact code is deployed on the same exact infrastructure. So it makes sense for me to perform load testing and validation and make have a environments that are equal in for all purposes, to avoid the configuration drift also on those. Yeah, because it's basically this is just will always make sure that your configuration for the resources that you deploy is actually the same an exact one. You can of course track the commits, and you can see the status of that because I have configured you can track the changes. You can go into the details of what has been done. You can see what has been changed where. You can also get to see the pushes, which probably is something that I looked at already, and get some details on who, what, when, and where the assigned work items. And also, yeah, I think in the repos part, what I didn't look at, I think, is also on branches, on ways how you can actually make sure there's quite a bit of built-in magic. And let me know if I'm boring you with this part, but it's important that you can actually empower branch protection policies to make sure that nobody deploys unsolicited directly to main or master, and that you require work items to be tied to any code that you try to submit as a pull request, and that you ensure that there's before you can do merge, that comments are resolved. You can limit the merge types. You can do a build validation, which is basically it does a kind of a pre-merge and runs the build process. What would it happen if you would mix your master with or integrate your new feature in there, and then you include this as part of the check when you do submit. Your code is built, your build pipeline is run, whatever tests are in there, whatever security scans are in there, it's actually executed every time you try to submit a pull request. And if it doesn't work through, your pull request gets a big red error message, which makes sure that you fix this before even somebody takes a look at your code, which is great.
These are actually quite great tools, as you mentioned, kind of all the check-in policies. I think over the years in my project, we found use for most of these things. just
Oh,
because
yes.
at scale this becomes very important. There is a question now. So
sure.
Are there any built-in possibilities to do migration for tickets, Wiki, or things like that from other project management or ticketing systems, specifically Jira, Confluence?
It's funny that you asked this one because that has come up. And last I checked, the only way was to actually write your own code. Both systems have APIs. You need to figure out the structure. You need to pull out these tasks. Like our dear friend Dmitry is actually mentioned using serverless components. I would just write basically a function that would just pull out all the items one by one and translate and push them into the DevOps. You know, the Logic Apps has a connector for that, but things may have changed because you have to understand that these ticketing systems use their own approaches, and this migration part is always the painful one. But you know, look into this. I don't have a clear answer on that. I sincerely hope that things have been changed and it's a lot easier to do the migration because once upon a time, even migrating tasks and tickets from one project to another one, or migrating from Team Foundation services to kind of keep the backlog of work items, you know, was really problematic. So, you know, sorry for the vague answer. A shorter way would have been to say, I don't know. But that's so this is also kind of really cool, but you know, you would kind of expect that from any good solution to allow you to have that. So on the pipeline side of things, you know, I have multiple pipelines, and one thing that I kind of didn't show in the branch protection policy that you can actually specify which part of the code, because obviously I'm using a single repository for everything. And my release process actually reflects that. But you can define also what's called code ownership. And actually here you can, for every pipeline, you can have a different branch filters and triggers. You can have a dev branch that all the things are getting built and released to a dev environment that's either one for everybody or one per each developer. And also you can actually, with this path filters, you can actually have one code base for everything, like mono repository. And then whenever a change is submitted on a specific area of the code for a specific folder, for example, you have a microservices architecture, you have folder for each microservice. Whenever microservice has been changed, you trigger a different release pipeline and build pipeline. So you can do all those things. So it's you know, again, when I discussed the continuous integration practices, I said, you know, there's, you know, the mono approach and multi-repo approach. And, you know, this tool doesn't enforce one or the other. You use what's best for you, for your organization, what works best for your team. You know, this is kind of about, you know, making sure that people, processes, and tools can work efficiently together. You know, it keeps coming back to that same exact thing, you know, and with releases, I'm not gonna change this. With releases, you can see that there are, you know, some failures and some good ones, but you can actually define a release, which is triggered in my particular case every single time there is a change. And you can see again that here we can have a separate one for pull requests as well. But since I do the pre-deployment thing, you know, I don't need to have a separate stage or approach on that. And you can introduce any additional, you know, branch filters here as well to kind of say, you know, this is for a particular branch. Yeah, and basically a couple other things for every of these stages. You can do a trigger. That's either after a specific stage. You know, this would reorder my process. You can have an artifact filters here for things that need to be ready. You can do this on schedule. You can do this as a pull request deployment. You can have approvals that are manual approvals before release to a stage. And you can have gates, which personally I love, because you can define and say, hey, I want, and this particular, what I'm looking at is pre-deployment gates. These are checks that you do automatically before you do deployment. The same way you can configure post-deployment gates, which means that, yes, I might have the production stage deploying automatically, but in my case, I have put myself as an approval. But you can actually introduce a post-deployment gate, which would run tests and check back that you're not getting any bugs on your test environment. Since your test environment is or should be identical to your production one, this is the way how you run tests for a period of time before you give an automatic green light to release to production. And of course, here you can include things that are, this is actually an extension that has been developed by somebody externally, which is basically doing a bug creation automatically if this part of release fails. So this gives you the chance to connect this back to the boards. Janis, do I see a question in your face?
Well, not quite a question, but a reminder about time. So
I'm doing it over again, yeah.
Well, we need to wrap up a little bit so we can give people a break and a chance for Q&A
Sure.
if they want.
I wanted to show some pre-built tasks. As you can see, there's a bunch of things on .NET Core, on Android, on various things, on releases, of course, to Azure, but not necessarily. There's a build tools, utilities, different utilities that you would like to do. You have a testing part where you can actually, tie those tests together and, do testing from App Center, packaging, various things, as you can see, not only tied to Microsoft. And all these can be actually extended by a great marketplace. Like SolarCube is there as a big one. There's quite a few on containers, and we're doing checks. So really cool. Play around with this, considering this is free. For test plans, of course, I'm gonna now wrap it up on this particular part. But you can define, the testing cases, what needs to be checked. You can see how these are being executed. You can run them directly from here, from desktop application, from web application. Select what kind of options do you want, which is the case connected. All these things interconnected here. But that's all I wanted to show for you. Let me switch back quickly to that slide deck thingy. 1 second, because anyways, I'll need to continue from that. So pricing, again, take a look at the Azure.com pricing details on DevOps. And, the call to action is start today. Create your own product. Put your code in. Do it. And with that, I thank you for your attention on this particular segment. Now I'm ready to answer your questions.
Yeah, just a comment for everyone. For now, we'll have kind of 5-minute Q&A time. And if you want to stretch your legs, that's totally understandable.
Does that apply to me as well?
Well, it would be healthy, nothing less.
I think so.
But we do have one question in the chat, so let me read that. So how would, in a few words, build process in Azure DevOps look like for commercial software that requires local desktop installation? XML versioning of some sort.
Well, basically, you would as an artifact in the end of the process create a package that would do the installation of the software, and you would integrate that package in whatever way you distribute your package. That would be like a super quick and easy way to do it. And Helmut, you can always contact me, and we can take this offline. I had the pleasure of working with Helmut, so I'll gladly help you to define that in more detail. So, but it's actually used for commercial products, Microsoft products, if you want an example. So we kind of do this quite efficiently. All right, any more questions at this second?
Doesn't look like it.
All right, I'll take a.
If something appears, then we'll take it, but we'll continue it at 5:45. So.
Thank you. I'll be back then. All right. You bet I am. So I'm back. Sorry. Yeah.
It's time to proceed, as I wrote in our internal chat. But yeah.
Good. Yeah, I hope you enjoyed that first part. It's obviously a bit short than 40 minutes to rush through. So but I'm glad that you joined this part as well. And now let's focus on. And by the way, let me know if that light is disturbing to me, to you. I can switch it off in the back end, but then it'll look even stranger in the darkness. All right, now let's focus on gaining visibility into your application's performance using Azure Application Insights. I'll try to be slightly faster with this part, and focus more on the demo side of things. So, first a bit on the agenda. Why exactly do I need application insights if you haven't, already figured it out? Then we'll take a look at what is it and how does it work. Then we'll, take a look at it in the demo environment. Have a summary of that, and I'll answer your questions. So, what does a visibility mean to you?
Carlos, could you share?
Yes, I did, actually.
We are curious to see.
Excellent. Lovely to hear that. I'm very sorry for this slight hiccup. I wanted to, I'm kind of surprised to see it rear its ugly end. You didn't see even my slide before that? Yes, you want to say? I'm terribly sorry. Let me just do that once more. I thought I didn't stop the sharing. So, dumb presumptions. Can you see it now, Giannis?
Yes, bright and clear.
Excellent. Again, agenda, briefly mentioned it. Why, what, how does it look, summary, and of course, my favorite part, your questions. So what does up or visibility mean to you? So different people are looking for different things. Some want to understand, how to optimize performance, how to use or how to make your product better through purely performance perspective. Others look how to detect and debug, any errors and catch any bugs and get traces of what's going on in the application. Others look for end-to-end diagnostic problems across the application, network, and the services used. Your managers or the project managers might want to see, how you're doing in terms of SLAs, of KPIs. Also, business side of things really want to understand what is the usage for your application, from what kind of devices are your applications being used, how do users travel through your product, how do they go through, for example, if you have an eShop, do they drop off at one point, do they have a bad experience maybe at a checkout or whatever else could be there. So. And application insights as an application performance monitoring solution is actually aiming to solve both the problem of visibility as well as the complexity of diagnostics for modern application. Because let's face it, applications have multiple tiers and components. And if you want to see the end-to-end kind of performance, you need to track it on multiple levels and do it in a smart way. And also in applications, if your application is big and popular, actually distributed over multiple data centers across the globe potentially, and are used by different clients from different browsers. And you also, want to check and see typically, the thing that we talked about before, which is the feature churn or how your features are being used. And you also want to see when you have a continuous delivery process, how the performance of your application changes when your new version was released. Did it go better? Did it degrade? Did it introduce any new issues and failures in the process itself? And as well, obviously, you want to quickly find and fix the issues. To address these topics, we have a product from Microsoft called Application Insights, which basically collects telemetry from each of the involved tiers, from devices and services and browsers for which the application is being used, and then the telemetry is sent to cloud, where it's stored, processed, indexed, and made available both for you for querying and also for the built-in AI machine learning models that do try to recognize anomalies and try to understand where the issues are coming from in your application. And you use that information then to identify, understand, and resolve any issues with out-of-the-box telemetry, as well as your own telemetry that you can send in. The great thing is here that you don't necessarily rely just on the things that Microsoft has written for you. You can actually add packages to your application and write your own custom telemetry to make sure and you can track the performance of a specific functionality in your code. You can basically send whatever makes sense to you and whatever you want to track as a developer or as a product owner to the cloud and add this custom telemetry there. And that is a really powerful feature. So what kind of sources of telemetry we do support? We have an outside-in monitoring, which is a URL, pings, and web tests from, at the time of the writing of the slide, it was 16 locations. Currently, it might be even more. What is cool about this one is that you can actually do a pattern that's called the app health check pattern, where you have a page in your application that doesn't actually show anything at all. But when you open that page, it calls the backend services and checks that all the dependencies are up and running and fine. And only then, when that is the case, it returns HTTP 200 code, meaning everything's fine. So you can use this outside-in monitoring to actually measure out how your application responds and whether it's in a healthy state from across the globe. As well, this gives you the chance to automate and do more smarter synthetic tests, where you actually have a test user that has the right to log in, that has the chance to go through the multiple business critical features in your product. For example, if you might be a shopkeep and you have your online store, you want to make sure that you find out yourself before your customers that a particular feature, like for example, ability to pay, is actually not working. And you can do that by doing a web test that actually simulates user experience. When they log in, fill the cart, then they try to, pay, and then, the payment either goes through or not. And yes, of course, there are some complexities that's associated with, specifically payment part, but you can make sure that you can get to that checkout, that you can call, your whatever banking service, and you can do that, with a fake, for example, card, and get the expected result. And by doing that, you automate the check that your business critical functionality actually performs. And when it doesn't, you get alert. You can either integrate that alert directly to create a work item in DevOps or any other, ticketing system that you use, or send a notification, or all those things at the same time. So your goal always, as a lady or gentleman operating a solution, is to find out about issues before the end users actually report those to you. That is the thing that you need to strive for. And outside-in monitoring is a great way, great functionality that I can use with ease in this product. Also observe the user behavior, how the application is being used, how the users are going through your funnel. How many users in the same shop example, how many users do drop off when they need to pay or when they see the price of a product they're looking for. And based on that information, you can actually figure out whether the people are dropping off from the process because it takes half a minute to load the products in your product catalog. We've seen the products where that happens. Isn't the best experience in the world, and probably the user will not be coming back to the product that has that kind of experience, right? But this gives also you a way to measure out, what, and using the built-in machine learning and AI tools to figure out, hey, what are the possible reasons for this happening? You might discover that on all the devices, your application is working fine and the users have great experience, with the exception of that one particular operating system, one particular browser, where for whatever reason, things just don't fly. And this is a way how you catch those particular cases. Yeah, of course, you want to see also, developer traces and events and things happening And whatever the developer wants to send, and again, that could be some custom metrics, that might be some stack traces where you run into some issues in the code. Yeah, whatever makes sense to you and your product, you can always track and send in. And that is, of course, again, another way how you can have a more focused development effort and focus on things actually being used and track how they're being used. Yeah, as well, again, observed application behavior, service dependencies, service maps, exceptions, logs from various involved services. You have that integrated in a single place, and you can easily query that. As well as the infrastructure performance, performance counters, you see, where the degradation is related to stuff that's actually coming with issues from the infrastructure itself. So what's the supported languages and platforms? So basically any platform, any application. Well, I would be careful about promising that you can do this with Delphi. That might not fly, but most of the languages are supported, and you can run that. You can check out the open source SDKs as well in the link here and look for them. But, we do for sure support most of the popular languages. So I hope that answers the question on, hey, is this just Microsoft stack that we support? So on the side of questions, do we have anything, Jan, thus far?
No, seems quite quiet.
Nothing from your side as well?
From my side, with the platform, that my question is always related to on-premise. Well, that's
obviously
the reality of my life.
Yeah, sorry to hear that.
So, what can I do from on-premise side? So obviously I'm limited by the data that I can share, but things like some of the telemetry, especially like performance indicators and things like that, could be useful to push to some place where it's easier to store. So how does that work? Should I open up connections to the cloud, or do I have to install something on-prem to do that? Or
there is a agent that is specifically targeted to be installed on your machine that has the web server on it, and it can basically, like, also I'm going to show the example of a slightly different application and how this performs, but basically also there, we the same way you would do this for a platform service for a web app, you would install on your web servers the agent, and there's an agent, and quite recently it got the version 2, which allows you to send the telemetry over. And of course, you can also add packages to your code that directly connects. You can add the application insights package that sends the logging data, whatever you want, your custom metrics as well to application insights. The main problem usually is in the question, hey, can you send, or is the customer of yours okay with sending the telemetry to the cloud? If that is not a blocker, there are a couple of ways, at least a couple of ways how you can make that happen. Yeah.
Thank you.
Does that answer your question? Because, like, even for languages that are not supported, you could, basically write that to file, and you can write a small web job that just picks these up and sends through the application insights, or actually what underneath there is an log analytics workspace. You can use the log ingestion API, for which you can basically send in anything. Yeah, so there's always a way around, as long as you can send telemetry to cloud.
Yeah, but with data, I imagine that it will be easier to talk about specific types of telemetry that you're sending over, where maybe you're not exposing as much of data, but instead of user interactions, which is not quite data, as long as we don't
exactly. But there's always customers. When you talk in banking space or specific countries out of EU, which don't feel really comfortable even sending telemetry over. So again, that is the question, the main question you ask, and if that's there's no definite no on there, then there's an agent. I will provide you a link, and as well with the presentations, and in regards to questions, I will follow up and provide to our dear organizers the list of links of things related to the questions you asked today. So that's my commitment to you, to follow up on those, and no matter from whom the question is coming, you just have to check in either with the Discord or the or the GitHub page that will be set up, where you will be able to get the content, the links, and whatever else goodies our dear organizers have prepared for you, right?
Yes, that all will be there.
Excellent. Then it simplifies my life so much more in this, that I can just follow up and not pretend that I know everything in the world. Good. All right. And this is also, of course, an intelligent application performance monitoring. So you can use the tool to detect and figure issues out when they appear. Here. And not hear from your users. It's always a beautiful support story when you call into a product support to say, hey, things are not working, and the answer on the other end is not thank you for calling, we'll take a look, but yes, we know, and this is what happened, and you'll have a fix then and there. Totally different. People just shine when I hear that you actually know about the issues with your product and you don't find out from them. Yeah, and the proactive diagnostics and all the great AI and machine learning stuff that's packaged into the solution. It's a great way to detect this quickly. And we'll take a look at the live metric streams and the dashboards in the demo part of the thing. And the triage component, you can use built-in metrics and stuff that's collected to triage and figure out why this issue is happening, where in your topology there might be a degradation in performance, there might be an external service that you're calling out that's way slower than expected, and because of that, connections are getting dropped and the user experience goes awry. Yeah, and once you have decided to fix an issue, you get also the context of the exceptions, the performance issues, dependency failures. For Azure component lifecycle issues, if there are any, no service is ever with 100% uptime guarantee. Issues do happen. Everybody is still a human. So, you want to also have a visibility in components failing maybe at certain times, or things that are not getting caught quickly, or you might be at the tail end of an issue, which is a transient one, which of course implies slightly different fixes to the code and introduce some exponential retries maybe and other things, or if you see that happening a lot, you have a basis in data to figure out that you need a redundancy in your service. So otherwise, which you could have a bit of a problem to selling to your management why this redundancy needs to be there. The ability to track the performance and also figure out and against your own SLAs and SLOs or service level objectives, which is something that you commit internally to, then you can say, hey, if we introduce this redundancy here, we circumvent the limited uptime of a particular service. We might have not known that it's only 3 nines when we sign up for this service. And hey, if we do this, then with additional cost, we can go, or rather increase the SLA and make good on our internal promise on this performance part. Yeah, and operationalize. Create alerts, on metrics, events, performance data, and have a webhook support, and basically send that alert to any service that can respond to those. Yes, through that you can either figure out a way how to scale up or out a service, how to create a ticket, how to integrate with any ticketing system that comes into play, or you can call the same Azure function is actually a really good example, because there might be a specific alert where that, hey, I'm actually having some files on the system and the local storage is running out, and I know that this particular issue I can solve by just cleaning some temp folders, because I have a virtual machine based solution. And then you can actually call a function which in turn through a hybrid connection or an agent on that machine can connect in, perform whatever cleanup operation, and you're fine and dandy. You can continue to fly on and your application performs. And without the visibility and ability to detect, triage, diagnose, and actually operationalize what you have, you're flying blind. and you get unsatisfied customers calling and informing you that your product is not working and performing well, and you never want that. You want to be the guys or ladies that are the first ones to find out, hey, something's up. Yeah, so what it can do, it can monitor and diagnose server-side application, and the same can be done also for monitoring and diagnosing client-side application issues. And you can add that, some snippets of code to your page, and then you can catch what's happening in a particular browser. And you can enrich the telemetry, as mentioned again multiple times now already, with custom metrics and events that you send in. And you can see, all the answers to all the various questions on not just, apples and what happens when people, or whether people click a button of a new feature they introduced. And based off of that, you can also, drive your product backlog forward, or modify, or rather influence it by saying, hey, we spent so much time writing this great feature, but people don't seem to notice that button. Let's make it bigger. That's a real actual impact that you can do just by checking out, hey, how are my users using my actual application? And this is, again, it comes back and will continue to come back to that story of, closing the feedback loop in DevOps and making sure that you actually, take ownership of the fact how your application performs. On the working side of things, the service, we have both web pages and your service that has application insights added on it, and it can be cloud service, it can be a web page that's public, and that can be an on-prem service with an application insights agent installed on it. Your background services and all those actually can send in the data to the application insights instance in Azure, as well as say that, hey, your external call is happening along, and then when the information is in there, you can do alerting. You can actually connect and write queries in KQL, which is our query language, and expose and have a Power BI report that periodically refreshes, that you can give your management and say, hey, you don't need to ask us how our application is performing. You can just open this here link and see what's happening. The same with Visual Studio. You can actually do a debugging and track and trace the performance in Visual Studio. And there's also the REST API for both ingestion and also for log search. And you can also do continuous export, because you might just need an application insights data that's last month, for example, and the rest you don't want to keep that in a storage that is hot. In a sense, you can query that data quickly. You maybe want to export it for historical purposes to a blob storage, which is the cheapest way you can store telemetry. Yeah, so there's also that functionality to do a continuous export of the data, because you might have a use for it in other different ways, not just archiving. But that's a good example to mention on how and where you can use that. Starting is easy. For Azure, services, there's just an extension which you can add, and it doesn't require you to redeploy this at all. And for more in-depth information, of course, you need to instrument and add packages and redeploy the application. Next time you do release, you can add this, and it's fine, and you can start to get the value out of this. So on the insights ecosphere a bit, for ingestion, application insights, does that for open source SDKs. There's the status monitor, there's Azure extensions for that. Also, if you're using, something like for on-prem world, the System Center Operations Manager for your monitoring, and there's of course an open schema and a well-documented API for which you can then, push in logs from anything that for which we don't have an SDK. And basically, any language that can make a web call can send that in through the API. For exploration, there's Azure Portal. I'm going to show a short demo of that one shortly. There's application map in there, which shows the dependencies. There's live application stream. There's a profiler and debugger, and you can actually, download the points in time and see the data coming in where your application failed. There's quite a bit of, and there's also, analytics part. Try to go through these components over time. When I'm doing the demo part. Sorry. Yeah, and of course the export and correlation. Microsoft Flows, Power BI, Blob storage. You can stream the data. And also get to it via the Visual Studio team services as well. Slightly dated slides. Sorry. Yeah, and support, as you can see, quite the wide one. There's a couple of new things which are slightly maybe not that new, but they're there. So now I wanted to show a demo, but how are we on time, Johannes? Because I have some slides on connecting the two together, DevOps and this. How would you like to see it progress?
Well, we
demo
have
now.
Something like 15 minutes currently.
50 or 15?
15.
Okay. Cool. All right. Let's then dive into a demo for 10 minutes or so, and then I'm gonna connect these things together and drive it home. Alrighty. So I'm gonna now switch it over. Come on, where are you? Stop sharing this and let's start sharing that. So, is it fine and dandy now? Can you see my portal view?
It looks beautiful.
Does it? Especially the fail request part, right? Anyways, this is cool. That good. So basically, this is just a dashboard like any other Azure resource dashboard that's created. And what's cool about these that in Azure, there's many services that do monitoring and log collection, and you can actually pin and create your own views and dashboards. In this particular case, we are using just application insights, and we're gonna go through a couple of components of application insights to figure out, and show some of the parts. So let's start with the application map, which a way to actually see. Let's include these as well, and now suddenly it becomes slow. Come on. Come on, demo gods. All right, and here we can clearly see that our application consists of two components. There's two different services. It's a retail app that has a testing happening on it, and you can see that there's a script problem detected automatically here, and we can see what are the services that the application is communicating with. We can get the statuses, we can get the counts of requests. We can automatically, I hope you can see this well, I'll make it slightly bigger. You automatically get information about, hey, what are the top failing requests? You see that for whatever reason, the employee creation process in my application is failing miserably. And I can take a look and see, hey, there's quite a bit of 404 errors, and I can go in and dive deeper in these and see, hey, it's suggested, hey, take a look at this particular issue at hand. And then you actually have the snapshots, and then you can see the performance of the functionality. You see, hey, somebody from South Central UK, it took 94 milliseconds to open this up. Then we tried to get this particular content piece, which for whatever reason failed. And you can see the troubleshooting report, which is something that you get automatically. You don't need to know how to write and query this information to get it. It's generated for you instantly. And here you have the chance to create a work item directly. Obviously, you can automate this, and I apparently in this demo environment don't have the rights to do that workbook, but basically you can simply create this as a definition and say that this is what you need to do when this particular issue happens. Yeah, that's a server-side view. We can take a look at the dependencies, dependency count and calls, and we see the top 10 response codes when trying to put a blob. Is actually we're getting a conflict. 409 is a conflict. So apparently there's a lease on the file, not yet released. So multiple processes are competing for the same exact resource. And in Azure, it actually takes a look at the signature, or rather the version of the file when somebody tries to write to it and it sees that it's trying to update it from an older version than somebody else is doing it, and does a conflict. So you can you figure out and see based off of that hey, I need to make an improvement to make sure that that doesn't happen. So these requests don't really fail here. So all right, that's that. So this is something that you get out of the map, and you see that those external things here as well, and you can see percentage-wise what's happening, and you can see that there's a web test that is running, or that's a browser actually, client-side information, and you see, and you can go in and investigate the performance, and this is all exactly like I'm doing it. There's no like magic that I do on my own by writing anything. We see that response time degradation, that suddenly on 16 there was a degradation on time, and then we can go back and see that hey, didn't we just release a new code on 16th? Didn't we just mess up the performance? Yes, you know, all the tests we did, the build succeeded, the release went fine, but for whatever reason the performance degraded. You don't want to find that out from your end users, or I wouldn't rather. Let's put it this way. Yeah. And again, you can see the dependency counts and response times, and you see the overall information on that, and you can drill down and see the samples. Yeah, again, this is a web page, end-to-end transaction details, and you can see end-to-end how this happens. So browser, server side, that's the resource requested on the app service plan. That again makes an external call. As you can see, the database is reacting rather fast, 7.6 milliseconds. But something between the click here and this actually takes quite a lot of time. So at end to end, this takes you know, half a second, which may be fine in your case or may not be fine. Your users might actually be dropping off here and not getting the best experience here. And the live metrics coming in, let's take a look at that one. Let's slide countdown. Yeah, you can see live what's happening live with your application. Yeah, new request received, and you can trace and see the telemetry. So there's a dependency issue. There's a trace being written on a virtual machine. That's a virtual machine. As you can see by the name, this is a container that looks like. So you know, there's interesting things you can see. This is the performance CPU total. So apparently there's a lot of CPU usage, and that could also explain some degradation of performance. Here, yeah. Can do search transactions. Let's see. You know, we can take a look at number of transactions happening. You know, again, end-to-end performance of that, and you can see what is considered to be a normal one. You know, pretty fast working one. Right. Availability. That isn't to mention what I mentioned about, you know, availability tests. As you can see, there's a specific tests running from specific locations, and you can see your response time on the different locations. And you know, kudos that you figured out. Hey, it would make sense to, you know, create a CDN to improve that response time on that. Yeah. So failures. I'm gonna speed up, Jans. I see you're looking at a watch.
I am looking at the clock.
Performance part, you know, you can see request count, you know, jumps, and of course, you know, the that also influences the performance. On the users, let's take a look at the user side before I switch back. You know. You can see the user experience, click through and see more insights on that. You know, from where they're using, what devices they're using, what's the browser versions, you know, user timeline, you know, a lot of valuable information on that, on sessions. And mind you, most of the stuff that you see here is collected automatically. You don't need to write any specific code to do that.
Yeah,
Events, yeah.
watching the demo, I kind of reflecting by myself. So a couple of years ago, when doing on-prem and collecting IS logs, creating using log parser queries to aggregate everything in Excel and then make it presentable for the management.
The good news is you can still do that.
Out of the box. Well, you can still do that.
Yeah,
but here it's out of the box. So.
Yeah, so you can see the funnels on. Oh, it's crashed on me, no? Best time ever to fail. Seems that my browser has said goodbye to me. How are we doing on time, Jans? Do I still have a bit? 5 snap. All right. I hope you get the gist of it. It costs about $2 per gigabyte of data sent in. And you get some of the data in for free. So here you can see what happens before and after. So, you know, when a specific action is performed. Yeah. So for example, you know, you specify a specific operation and you whatever, I'll just pick something at random and actually generates, you know, working, you know, let's take a look at 10,000 sessions and see 31 sessions went from, you know, opening a home page, then to a different home page, then click at the button. And this is how you can actually get a full overview. Who, when, what, mega cool. All right, so that's the last one I wanted to show here because I actually do have some slides. This is always me and the demos. I just, you know, forget time because, you know, these things are really cool, and it's so cool that you don't really need to write too much code of it. Janis, please confirm you can see the slides.
Yes, they're visible.
Excellent. So now I'm going to try to quickly join the two together. So, you know, with continuous monitoring with application insights, again, native integrations in Visual Studio and Visual Studio Code allows you to actually configure pre and post deployment gates. So the things that I showed you, the performance on alerts on web tests, you can actually set this up if your prod and dev or a test and environment and prod environment are equal. You set up the tests, you run them. They don't share the resources. Hopefully, yes, it is a bit of an extra cost, but this gives you a chance to use quality gates that after you have deployed to test environment, which is equal to production, you run automated tests. And if these tests succeed, you can automatically deploy to a staging slot, which is again tested slightly less, just checks that the uptime is that it's up, and you switch, and your user gets a 0 downtime release of a new version with your ability to fail back. And of course you can integrate and track bugs and work items in Azure boards and GitHub, of course, as well. And you can run code level analysis in production with snapshot debugging and profiling. The one thing that I skipped over in the demo, that you can actually get a failure and download the profile there and actually load it up locally and see what happened in your code and what are the exceptions that were thrown there and what happened. And you can use that information to figure out your issue. And, you know, application insights is also for end-to-end. I showed you, you know, the application map, how the calls are going through where. This one is slightly more informative, shows external services and the calls, and also, you know, the failing requests and slowest responses. You know, and also you can track the distributed transactions. Yes, there's a slight trick. You need to figure out, you know, a transaction, you know, how you pass through different services, the same transaction. You know, imagine microservices. You kind of need to have a tracking ID for each request to have a proper end-to-end tracking of that if it goes through multiple services, but can be done, has been done. Yeah, and, you know, and you can drill down in the code level. And actually, what I personally really love is the ability to understand the user behavior, and you can use that information to understand how to plan and what to focus on. You know, either make the new feature more prevalent and visible, or focus on improving the actual performance. You know, and if we look at the price or the phases, yeah, And development part, of course, you want to integrate with your IDE and track and see how it's going, and also do the deployments on your dev environments, run load tests to figure out how well or not well it's going to be performing, and figure out even before you go to production whether it is acceptable or not, and obviously use that information to create bugs in the development phase of your process. And in the operations phase, obviously you onboard this through pipelines or via code snippets that you add. You do use pre and post deployment quality gates, again with integration and ability to create a bug item whenever it fails. And you track and monitor both the health, availability, reliability, performance, infrastructure parts. And you do run code analysis and alerts and notifications, and focus on the performance and usage of your product to ensure great user experience, or at least have a control over what's happening there. So remember, your task is not just to code, ship, and forget. You have to own what you write and commit to continuously delivering value, whatever that is, to your customer continuously. With that, I thank you for your attention, and now I can hear all about your questions if there are any.
Okay, let's give a moment to people if they want to add some questions, as the chat has been quite quiet for the last few moments. So if nothing new appears, we'll probably want to switch to kind of next slides and wrap up the meetup so people can go on with their evenings.
Yeah, I hope there are no questions, because everything is crystal clear, and not because everybody just fell asleep.
Okay. So this, well, you can still write the questions in chat, and we'll do our best to answer them. But with this, we kind of want to conclude the first meetup that we have organized. There are next ones to come. As I mentioned, we are planning at least 4, hopefully more. The next one will be we'll have a placeholder later out later today, but it's for March 18th. So same date, different months. I would ask every one of you who wants to participate in the discussions in between and just kind of have more open talk, or join me for coffee breaks during the days, join the Discord group. Let's see how active we are there and how many people we can get on there. I saw already a bunch of you joined there, but everyone else is also welcome. I want to remind you to register to upcoming these fundamental training days. So if you want to get started with Azure and want to get vouchers for free certification, that's always nice to do. Join there, look out for dates. These are organized regularly. So if you the nearest one is already completely full, there's always the next one. And I would encourage you to look at the materials and documents available either on Microsoft Learn or then in the newsletter. But yeah, with that, I think we are concluding the first meetup that we have had. I think it's a good start of the year. We are going places, so join us.